There's 4 different ways of generating electricity. We have alternating current as demonstrated by a generator. This is a model of a generator. We have a battery that has direct current electricity. Direct current is created by chemicals. We have what is called photovoltaic cells as demonstrated by our calculator. And then finally, the most basic electricity that you can find in nature that you can actually make at home is called static electricity. Electricity is created by charges. So where do those charges come from? All atoms have an electron and they have a proton. They are opposites. The proton is a positive charge. The electron is a negative charge. Opposite charges attract, like charges repel. Most of the time, charges are in balance. There is an equal number of positive and an equal number of negative, and those charges cancel each other out. However, what happens when those charges become imbalanced? It is the electrons that have the ability to be mobile. And when electrons are able to move, we call that a current. And when that current happens, we will have electricity. Probably the most popular way, when we get shocked, we call that static electricity. Now, most people don't have one of these at home. This is called a Van de Graaff machine. It has a rubber band in it, but you might notice it has a cord. This cord is being used to spin the rubber band. I'm not using the AC directly. So the rubber band in this machine is going to create the static. And boy, does it create some static. So let me demonstrate to you that this instrument will have a charge in it. And watch what happens to the pie pans and see if you can explain the reason why they do what they do. Now, sometimes I like to have fun with my students, and so what I tell them is, take your balloon and pretend like it's a wand and wave it at the pie pans and say, Repellioso. So let's try this. Ready, set, Repellioso. Oh, wait a minute, what is going on here? All right, the only way that those pie pans can float off the top of this apparatus is because they must have like charges and they're repelling each other and they're flying off. And that's a really cool demonstration. My kids can't get enough of it. They want to see this over and over again. Now watch what happens when I have opposite charges. And I'm going to take this pie pan and bring it close. And you can probably hear that. I'm actually creating mini lightning right now. Okay? Now, the reason why we don't use static electricity is because it's not very sustainable. It goes really quickly in a big burst, and then it's gone, and it can't really be used. And so this Van de Graaff is being attracted, the electrons in this Van de Graaff are being attracted to the pie pan, and that's why they're creating this big old spark. You got to be very careful. I'm going to close this machine off. And then it has a residual spark in it. That means there's some spark that built up in it, some charge that built up in it. And so I'm going to let that spark go, and now I should be able to touch it safely, and it's not sparking me anymore. Okay, that's Mr. Jose from Exploration Place. Until next time.